Hello everyone, my name is Nneka Ayidu. We are here to present a research project titled User Identification Using Web Interaction Behavior under Artificial Intelligence and Application. The main aim of this project is to build a machine learning system that can be used to classify users into different browsing activities using MATLAB.
Hi everyone, my name is Joshua Ikechukwu Adiele. I'm the group leader for Group 30. We use the dataset from Gazelle.com, an e-commerce website that recorded every customer's interactions before closing in the year 2000. The dataset was donated to the competition called KDD Cup 2000. The training file has 234,954 unique customers recorded across 296 columns. The dataset was not straightforward. The first time we ran, MATLAB returned a 0 row from a 304 megabyte file. I traced the problem to a non-standard line endings in the file format and fixed it by switching to read matrix with the file type text parameter. As you can see, it worked. We have 234,954 rows and 296 columns. All 296 columns were automatically scanned and found 184 usable data. The 5 key columns against the dataset named file were confirmed, but the most important thing discovered was that every single customer ID appears exactly once. The dataset was already aggregated, one strawberry per row user, which meant identifying individual users was impossible. The discovery forced the entire group to redesign our approach.
4 key features was extracted in this work, which are the time spent, page viewed, hour of the day, and click sequence. Click sequence was used to create a group which are called the light, heavy, or moderate browser. During the process, we had some challenges, though our initial plan was to work with the most active 50 users. But because the data set has only 1 row per user, it resulted to a 0% accuracy, knowing that 0% accuracy is not enough for a model to learn from, according to Quam et al. 2024. To solve this problem, we introduced click sequence. The click sequence now was used to create a label, and then after creating the label with the click sequence, we remove the click sequence to avoid data leakage. The model then find a genuine pattern in terms of time spent, page viewed, and hour of the day.
My name is Sohaib and I was responsible for training the model and evaluating them. First of all, I divided the dataset into 2 parts, 70% for training and 30% for testing. And then I applied z-score normalization after splitting. Then I used 3 different classifiers. Decision tree achieved 88.5%, KNN achieved 87.7%, and random forest came out on the top at 88.6%. And then as you can see the confusion matrix, row 1 is light browser, and you can see the 1310 correctly classified out of 1321. That is around 99.2% accuracy on the class, and also our class cross validation score of 89% is only 0.4% point away from the test accuracy, which shows that the model is stable and not overfitting.
Hello everyone, my name is Zay Yar Aung. I will explain about the XAI and Responsible AI. For the XAI, I use for the decision tree instead of random forest. Because the reason is random forest is a breast bulk and it's run a lot of trees and give you a majority bulk with no single readable structure. And the decision tree shows every effects rules visually, and which means any prediction can be like traced and audited. And looking at this feature importance chart, time span is the stronger predictor, followed by the page view and hours a day. And this tells us that how long someone stayed on this website. And here is the actual decision tree. The very first split at the top is on time span and confirming our XAI finding. And this card scatter plot shows all 5,000 user plot by time span and against page view and colored by their groups, like blue cycle are light browser and orange plus sign are moderated and green crosses are heavy. And this project will require according to the GDPR compliance, and our models use no demographic data and every decision is auditable. And any life system must include monitoring and
Random forest was our best model at 88.60% accuracy, with a cross-validation score of 89%, confirming stable generalizable results. Time spent is the strongest predictor of browser behavior. Class imbalance is a known and documented limitation. Our pipeline prevents data leakage, uses correct normalization, and is fully reproducible. All deliveries are complete.